Hi friends, how are you? A pleasant, wonderful good afternoon to all. So here, firstly, I thankful for our secretary Dr. R.S. Praveen Kumar Sir Garu for introducing such these programs. And my topic is gaseous state. Before going to topic, I need to ask you some questions in our daily life. First one, mainly in summer when we are traveling on long road traveling, so here the vehicles like bike, car, buses, etc., the tires of vehicles will blast. Why it is? And second one, we have bun. Why it is spongy and fluffy? And here we will use, many of members will use spray. How the gas is compressed in the bottle. And my questions are, here when we traveling in air, the hot air balloons, how they are flying. These all questions you will be answered by watching till my end of my PPT. So let's go to topic. Before, here I want to ask you one question. Here, what is this? Yeah, this is a book which has mass, and when I am placing here, it occupies some space. So a substance which has mass and occupies space is known as matter. Yeah, it is known as matter. So here example of matters. Example, stone and book and pen, table, etc. These are the examples of matter. And classification of matter on the basis of physical states at room temperature. Matter has classified into 3 states. First one is solid, liquid and gas. What are that? Solid, liquid and gas. Okay. Here in general our molecules have 2 types of tendency. First one is mutual attraction tendency and second one is escaping tendency. Here if mutual attraction tendency is high, then escaping tendency, then it is considered as solid, and if mutual attraction tendency is equals to escaping tendency, then it is classified as, the matter is classified as liquid. If the mutual attraction tendency is lower than escaping tendency, then the matter is classified as gas. Okay, have you understood? If mutual attraction tendency is high, then escaping tendency, it is classified as solid. If mutual attraction tendency is equals to escaping tendency, then it is classified as liquid. If mutual attraction tendency is lower than escaping tendency, it is classified as gas. We will discuss the differences between solid, liquid and gases. Okay. So here for explaining that, by experiment I will explain you. Here I took a syringe which is filled with chalk powder. Here I filled chalk powder in syringe of 20 ml. When I am applying an external pressure to the piston, okay, here I am applying external pressure to the piston. Yeah, it is not changing its state. Yes or no? It is not changing its state. By this we can say that if we, in this syringe, it is a solid, no? So when we are applying an external force, it is not changing, because here in this solid have the intermolecular forces is high. Take another example, stone. Here I am applying pressure, it is not changing its state. Yes or no? So it has intermolecular forces is high and the intermolecular distance is short. For that it is not moving. If you see the figure 1, in figure 1 the intermolecular forces have bonded tightly. For that it is unable to change its state. And next, going to gases, if going to gases, liquid, I am taking 20 ml. Okay, when I am applying an external pressure, yeah, it is moving slightly. Here it is came, okay, it is changed its state. It means here in this liquid we have the intermolecular forces is lesser than solid and the intermolecular distances are larger than solids. So the state is changing in liquid. Next, here going to gases, here I took 20 ml, it is empty. So it is filled with air. So when I am applying external pressure, wow, yes, exactly. See here, it is changed its state, yes or no? Yeah, it is changed its state. By this we can say the intermolecular forces is too much less as compared to solid and liquid, and the intermolecular distances is too high in gases as compared to solid and liquid. And here I took a stone. When I am placing here, once observe it carefully, when I am placing here and I am placing it in plate, okay, is there any change in solid substance? No changes. In this substance no changes occurred, okay. It means here it have a definite shape and volume. For that it is not changing its shape and size. And next, going to liquid, here I am taking water and pouring it in the small glass cup or small cup. So observe it, what changes you will observe. And next, pour in flask, okay. Here before I am pouring, the shape of water is, yeah, glass beaker shape, and if I take the glass, when I am pouring it inside the glass, so here it occurred in glass shape, and the shape of water in flask is flask shape. By these three, by observing this all, we can say that the liquid will occupy a container shape, okay. Have you understood? Here it occupied a container shape, but the volume of water is same. Again it is same in beaker, yes or no? Here by this activity we can say that liquid have a definite volume, but it didn't have a definite shape. The shape is container shape. I am going to liquid. Here we know here I will say you, here we have air, but it is invisible, so it didn't have any shape and volume. Next, when I am applying an external pressure force on this, it not changing its state, yes or no? So we can say that it is a rigid body. Rigid means by applying an external force, it won't changes its state and size and shape, okay. Friends, here liquid we have, here the state of liquid shape, here see, yeah, okay, it is changing its shape when I am putting an finger. So by this we can say it is not a rigid, By applying pressure, it is changing its size and shape. Going to gases, here when I am applying force, it is changing its shape and size. So, it is not a rigid body. And the examples of solid are, in our daily life we know stone, and we are writing pen, using book, etc. And for liquids, it is a water and gasoline, petrol, etc. Next, going to gases, the examples of gases N2, H2, air, etc. So, by this, next, measurable properties of gases. I will explain you with example. Okay. Here I took 20 ml. It is a empty. Okay. Are you able to see? Yeah. You are here. It has 20 ml. It is empty, means filled with air. Okay. Here when I am applying pressure to piston, then the gas is compressing. Yes or no? You are able to see this. When I am applying pressure to piston, then it is compressing. By this we can say the gases have compressibility nature. If I leave it, okay, I remove the pressure, wow, the gas is expanding. By this I can say the gas have expansibility nature. Okay. When I am applying an pressure to this gas, okay, here the molecules will collide each other and walls of the syringe, and here colliding with my finger. Here colliding with my finger. I am here observing, I am feeling pressure on my finger. Yeah, I am, yes. By this I can say that gases exert pressure. Okay. And next, if here if we take gas, I took an gas, okay. Here balloon contains gas. So, listen, here it is a gas. Once catch it, I am leaving it, okay. Wow, it's moving now. Yes, it's moving. And if I throw a stone, it will fall down. It won't move because it has more mass, okay, and it has less mass. It has more mass and more density. And for gases, it has less mass and less density, so it is moving. By this, we can say the gases have low density. And I want to say you this, here spray. Many of members will use spray. Here when we spray this, now the gas will enter near me to a person far to me. Means here they will feel a pleasant smell because the diffusibility of nature. I want to say you one feeling in my class which is held in our college, that one day I sat at the corner of my class. My friend came late. So, when he came late, after sometimes I felt a pleasant smell. Why it is? After when he came near me, I asked him, oh, when you came near me, I got a pleasant smell. I felt a pleasant smell. Why it is? I asked him. ए भाई क्या चल रहा है? He said me, a fog चल रहा है. Here means here he just said me that and I know that here diffusion, the diffusibility of gas traveled from near me to a person other when I did an experiment. When he entered, it came near me. By this we can say the gas have diffusibility nature. Okay, when I did this experiment, okay, the balloon moved randomly. Yeah, it is moved randomly because it has high kinetic energy. Instead, here in case of solid, it won't move because it has less kinetic energy. In gases, it has more kinetic energy. Okay friends, have you understood what are the measurable properties of gases? Next, to explain these measurable properties, some gas laws were proposed. So now I am entering to the topic, gaseous law. Okay, gaseous law. Now in this gaseous law, first one is Boyle's law. Boyle's law states that at constant temperature and number of moles, the pressure of given mass of gas is inversely proportional to the volume of gas. By this statement, we can see if pressure increases, the volume decreases. They are inversely proportionality. If pressure decreases, the volume increases. So P is equals to K by V. Here P is the pressure of the gas and K is the proportionality constant and V is the volume of the gas. PV is equals to K. Okay. For 2 moles, P1 V1 is equals to P2 V2. And here I want to, this is theoretically, I want to explain you by practically. Okay friends, are you ready? Yeah. Now I will explain you with practically. Here I took a syringe, okay, which is empty, okay, which is empty, means it contains gas. Yes or no? It contains gas. Here I am applying and pressure, here it has 20 ml, it means volume. The gas volume is 20 ml. And when I am applying and pressure, oh, the volume is decreasing, right? Yeah. If I decrease the pressure, what will happen? You listen and see carefully. Okay? Yeah, volume is increasing. If I increase pressure, the volume is decreasing, and if I decrease the pressure, the volume is increasing. Yes or no? By this experiment, we can say pressure is inversely proportional to the volume. Okay friends, this example is states that Boyle's law has proved. And by coming graphs, here we know the proportionality relation. If pressure increases, the volume decreases. If pressure decreases, the volume increases. For curve 1 at constant temperature, here first constant temperature T1, when pressure increases, the volume decreases. Okay friends, when pressure increases, the volume decreases. As for T2 is same, similarly T3 also. If pressure increases, the volume decreases. And it is plotted at a constant temperature. So it is known as isotherm. Okay friends, isotherm. Iso means constant and therm means temperature. Isotherm means at constant temperature, the graph pressure versus volume, they are inversely proportionality. So this is, if it increases, the volume decreases. If pressure decreases, the volume increases. Next, going to graph 2, here when pressure increases, these are in inversely proportionality, means P is directly proportional to 1 by V, we know that. So if P increases, 1 by V also increases. Yes or no? For curve 2, if P increases, 1 by V also increases. They are proportionality. Then the curve is passing from the origin in a straight line, okay, in a straight line, and In our live daily examples are, here we have spray. I asked you a question that how the compressed aroma, large amount of aroma is filled in small amount of volume by applying Boyle's law. Here these are in inversely proportionality. By this they applied and high pressure, okay, for low volume, and they have filled the bottle. Next, going to Charles' law. Charles' law states that at constant pressure and number of moles, the temperature of a given mass of a gas is directly proportional to volume of that gas. Okay friends, at constant pressure and number of moles, the temperature of a given mass is directly proportional to volume of that gas. Means here if volume increases, the temperature also increases. Okay friends, if volume increases, the temperature also increases. If volume decreases, the temperature also decreases. V is equals to kT. Here K is the proportionality constant and V is the volume of the gas. T is the temperature of the gas. Okay friends, this is theoretically. Now I will prove it practically. Okay friends? Okay. Here I took here this is a hot water friends. I am taking hot water. Okay friends, I am pouring it in a beaker. Okay friends, I am poured a hot water. I am taking a bottle and placing a balloon and closing the mouth of the bottle. Okay friends, I closed the balloon by, and when I am placing in hot water, wow, see here what happened? The balloon volume increased, yes or no? The balloon volume increased. By this we can say that, have you understood? If the temperature increases, the volume also increases of the gas. Here when I increase the temperature of the balloon, then the volume also increased of the balloon. Next, second activity, that here first I am pouring a colored water. Okay friends, I am pouring a colored water in the plate. Okay friends, here I am pouring a colored water. Once observe it. Okay, colored water. Here it is a colored water. I am placing a candle. I am lighting a matchstick. Okay, I am lighting a candle. Okay friends, have you observed this? And I am placing a conical flask. I am placing a conical flask. What changes you will observe? Observe it friends. Wow, a colored water is rising up. Why it is? Why it is? Because friends, here when I lightened here a candle and placed a flask, in that area the temperature is increasing by the candle. and here the gas will be heated and it tries to expand, but this place is insufficient. For that it escapes from the mouth of the conical flask. Then here we can say by this, when it is here the temperature is low, okay, the pressure is decreased and our atmospheric pressure is constant. This constant pressure applies an external force and the liquid rises up. It means here temperature increased and the gas also increased, volume of the gas also increased. So they have proportionality constant. This proves Charles' law, and our examples of Charles' law are, here I asked you why the bread is spongy and fluffy, because they will use yeast, okay friends, yeast, and it releases carbon dioxide and it releases carbon dioxide na. Then here when it releases carbon dioxide, then the amount will be reduced, then it will be like spongy, okay friends. And I asked you question, when we are traveling long journey in summer, because here the temperature in summer is high, when temperature increases the volume of tire is also increase, but the space is insufficient, so it will expand and blast. This is the reason, okay friends. These are the examples. And next, going to graphs. Here we know that proportionality constant, they have proportionality relation at constant pressure, so it is known as isobar, okay friends. If volume increases, temperature also increases. Next friends, going to Avogadro's law, it states that at constant temperature and pressure, equal number of gases contains equal number of moles. So friends, V is equals to Kn, V is directly proportional to N, V is the volume of the gas and N is the number of moles of the gas. Here friends, we will prove this. If I take a large amount of gas and small, here I took, it is large amount of volume and it contains large amount of gas, and here it contains large number of moles. In case of small balloon, it contains small amount of volume, small amount of gas and small number of gases, because here by this we can say, if large amount of volume contains large amount of moles, if small amount of gas contains small amount of volume contains small amount of gas, they have proportionality. It proves Avogadro's law. By graph, if V increases, N also increases, they have proportionality. Next, by these three equations we have drawn a ideal gas equation. By combining these three, we get V is directly proportional to Nt by P. Here if we remove proportionality constant, we get R, it is the universal gas constant. V is equals to nRT by P, PV is equals to nRT. Here P is the pressure of the gas, V is the volume of the gas, N is the number of moles, R is the universal gas constant, T is the absolute temperature. By here we know P is the atmospheric pressure, it value 1.01 into 10 to the power of 5, and V is the, at STP we have 22.7 liter per mole, and N is the 1 mole, by, and T is the absolute temperature 273.15 Kelvin. By applying this, we get R is equals to 8.314. Here we know P is the Pascal, and for volume meter cube, by, and N is the 1 mole and K is the, T is the Kelvin. It means Pascal meter cube for Kelvin mole inverse. So by this I want to conclude these gaseous law are used in our daily life. So by this I am thankful for our Dr. R.S. Pren Kumar Garu and our principal sir and our lecturer for giving and supporting for this program. Thank you.